Hey, hi everyone, welcome back to HDI Learn channel. I hope everyone doing well, good and safe. And we already discussed about the basic concept of the OSP app, and we'll in this video we'll talk about what is the OSP app area, why it is needed, and how it is working for the single area as well as multiple areas. So we'll discuss about the first what is the OSP app area. That means it is the logical group of the router. So yeah, it is a logical group of the routers. That means let me open. But before that, we'll focus on why we needed the OSPF area. Now let's take example. You have 300 plus router in your network, and let's take example. This is the three routers which is connected to the main router. That is, we can consider this is a master or core router, and other will as a working as a slave or client router or distributor router. And in this router multiple router is connected like this, and similar way in this router have the multiple router connected, and this is core router having the good configuration, distribution router having the less configuration, the less memory than the core router. And the last which is there here, the last router will be considered as a, we can say that access router, and they have very less memory, less as compared to distribution as well as core. So this router will consider as a distribution, and if in case it's all complex network. Now, it let's consider we have 300 plus router in this network, and if in case any network or any new things is added, they will be sending to each and everyone, and then they will be sending to this one also. That's what is happening here. This is every request. It is going to be each and every router, and the router will don't have the that much memory. Let's take example core router having the multiple multiple LSA requests, that is link state adverse and this router having the good capacity. But what about this access level router? If any changes is happening in the network, each and every router will get the notification as well as the database. So the main thing is within they have maintaining the same database, and if any things, any changes will happening, they will be getting the each and every request. So that's what the area concept will come. Now the concept, the area. Let's take example. I have configured this one into the one area. I have configured this one into the one area, and the third one I have configured like, let's take example, I have configured area 20, 10, 20 and 30, and the main it comes under the 0. So what's happening? The distribution, if any network or anything is happening, that changes will occur, impact will occur only within the area. So that is the first concept, or that is the area. That means we have, this is the logical group of router. That means if in case I have multiple router, and this router is not maintained or is not going to be same memory, same request. So if the area it's coming the logical group that comes under area 0, area 10, area 20, and that's what, that is OSPF area. That is they were coming the concept, it is the logical grouping of the router. And what is, if any changes happening into the area, it will impact all routers. So how, which router we have connected within a network, within an area, if any changes, if any new network is added, they will be changing the routing information. They will be sending, that is LSA, LSU, LSR, that we already discussed, and they will update the information in their routing and their routing database as well as routing table. And the third is all router is maintaining the same database. That's what we already discussed. If area is not there, and if you have the 300 plus 300 plus 300 plus router in there in your network, and if in case they are continuously sending LSA as well as request update for each and every router, so core router having the same core router having the good memory, but the distribution as well as what are the access router we have, they don't have. So they will be saying, okay, I don't have that much database that can maintain the particular request from this particular network, and each and every network they will be sending into the area. So that means the database is maintained by router. Now the resolution that we already discussed, the if you have the 300 plus router and in complex network, so it can be defined into area 0, area 1, 10, that you can use. And this, and if any changes happen, it will not affect to all network, it will affect only within a area. So that what is the conclusion? The if in case within an area that information or if any changes happening within an area, so they will be utilizing very minimal or very less database. So that is comes under the OSPF area. Now, what is the condition? Let's take example. Okay, this router multiple its connection is happening, and okay, let's take example. This router having the multiple, and this router is area 0, that is called as what is backbone area, and the router should be connected which is the area 0. So all routers should be connected to the this router, that means area 0. And let's take example area 10, area 20, and area 30. So but all area must be connected to the area zeros. Okay, and first this we can say that this is the area 0 is the backbone, and all other is considered the non-backbone area. That means area 10, area 20, area 30 will call about what is area non-backbone. So area 0 is the backbone area, and all router must be connected to the area 0. And every router should have the at least one area border router. That means let's take example. So this router is connected to the area 0 as well, area 10 as well. That means it is mediator, or it is the connecting between what are the requests coming from this router to the this one. That means this router will work as a ABR, that area border router, and that means this interface and this interface they are communicating to each other between the area 0. That's what this is router comes under the area border router. So that is the things. And if we are talking about, already we have discussed about the advantages, this link state routing and the algorithm, they will be calculating shortest path first to reach the destination. But one disadvantages of this OSPF is it is consume more CPU and it is very complex to design. If you have the single area, it is very easy. But what will happen if in case it is coming the more than one area? So that things will happen. That means if you have the 1000 plus router, that is very complex to design that things. And we already discussed about our OSPF area, but the problem here is OSPF area is if you have the multiple router is there, and this we can say that this is the core router, this is distribution router, and this is access level router, multiple access level router. And if in case you are getting any request that is comes under the any router or any network changes, that will affect to entire router, and if it is going to be changed or if it is going to be add new network, the database is going to definitely full, and the area zero, they will be saying that, oh, I am receiving multiple LSA request, that is like adv link state advertise. So that's what the OSPF area is coming. They will be defining, they will be distributing the 10, 20 or 13, what are the area you have. And if in case, if they are doing any changes within a network, it will affect only area. And this area zero is considered as the backbone. So that is the concept of the OSPF area. And the rules we already mentioned that all areas or all router areas must be connected to the area zero, that is backbone area, and all if one backbone is, other will call as the non-backbone. So and one AB area border router, that means they are connecting with the multiple interface or multiple router, they will be going to be send and receive the routing information. So that's all the concept of the OSPF area. In next video we'll talk about what is the OSPF single area configuration. That means router OSPF process ID, you can given in process ID. Let's take example. If you are the ISP and if you have the multiple customer, like let's take example, you have the 300 plus customers. So that is defining that you can identify using the process ID, and that you can give the number 1263565353, that you can given the number to identify your customer, that is router OSPF 123. You can you can give or you can utilize this process ID number. And the next is you will be using the network ID, or you already know what are the network ID, that is. And but the thing is that wildcard mask is the nothing but opposite of the subnet mask. Let's take example. If you have the network of /24, that is 192.168.168 1.0. That means if it is subnet mask is 255.255.255.0, it is opposite, that is 0.0 and last octet is 0, but it is in wildcard mask, it is the opposite. That means if you have the subnet mask is 1, in wildcard mask it is the 0. That means if you have the 255.255.255.0, that means the subnet mask is 0.0.0.255. That is the wildcard mask. That means it is totally opposite of the, you know, opposite of the subnet mask. Let's take example. If you have this, you have the 255.255.255.0, that means class C. If in case, if it is, we already discussed about, this is the subnet mask. And if it is, when it comes under the wildcard mask, the 255 is coming 0.0.0 dot last octet is 0, that means 255, that is wildcard mask, means it is the opposite of the subnet mask. And in OSPF, you need to be used wildcard mask. So that is the overall concept. So in next video we'll talk about the configuration part, how it is come under the, how we'll configure for the single area and how we'll configure for the multiple area, and which is the ABR area border router, which is the area zero backbone not backbone area. So we'll get the more idea into the next video. If you are getting some knowledge from this video, please like and subscribe my YouTube channel. Thank you all.